Hello, Internet, and welcome to the OWASP DevSlop Show, a hacker jungle gym built on DevSecOps disasters. I'm Amy, and I'm with my co-host, Nikki. In this episode, we will unveil the mystery of mobile security. First, we'll overview mobile application security threat vectors, then delve into the components of an Android application by reverse engineering a COVID-19 app, and finally explore the OWASP Mobile Top 10. We'll then leave you with the next steps to continue learning about mobile security. Take it away, Nikki.
Thanks, Amy. Our guest today is Jasmine Jackson. Jasmine shares her passion for information security by presenting and teaching workshops with over 10 years of experience. She is currently the Jeopardy-style CTF coach for the inaugural US Cyber Games. She is an adjunct at Drexel University and the City University of Seattle. She has several certifications in secure programming, web app pen testing, and cloud security. She has a master's degree in computer science and currently works as a senior application security engineer for a Fortune 500 company. She has presented her work both domestically and internationally for such conferences as Diana Initiative, Bugcrowd, Blacks in Cybersecurity, and NotPinkCon. Welcome, Jasmine.
Thank you for having me. I'm so excited. So let's get started with demystifying mobile security with the COVID app. So let's jump into threat vectors of mobile security. So on this slide, we have sample threat vectors from Now Secure, and it's broken by different sections. Most people, excuse me, do not think of their mobile devices as mini computers, but it is. And so this threat vector illustration shows that. So I'm only going to explain a few of the threat vectors shown on this screen. The first, under phone SMS or SMS phishing. So SMS is text. You could think of this as text phishing. So an example of this is I'm with T-Mobile. I received a text message saying, "Congratulations, you've won a $100 gift card from a random number that I didn't realize." So that's an example of SMS phishing. Another threat vector under system is rooting or jailbreaking. So most times when you use your cell phone, you're using it as a standard user. And with rooting and jailbreaking, what happens is you essentially use your phone in all of its capacity, meaning accessing the system files and system folders. And with that, you can start deleting system files and folders and pretty much make your phone inoperable if done incorrectly. So, a fun fact, if your phone is under warranty and you root or jailbreak your device, you have essentially invalidated your warranty. So rooting and jailbreaking is very serious and should be done sparingly. So as I said, I'm not going to discuss all of these threat vectors, but I have included a link at the bottom if you would like to know more and how Now Secure devise these different categories and learn more about these threat vectors, you can click the link below. So this talk will only focus on Android. So my iOS users, my Apple users, don't come at me with pitchforks. Why Android? Well, Android is open source and severely fragmented. So mobile providers can add custom code on top of the Android operating system for specific devices. So I have a Samsung A32 with T-Mobile. and someone else can have a Samsung A32 with Verizon, and our phones could be different because our mobile providers can add custom code to make our phones handle differently or operate differently. So this leads to interoperability problems or issues, which for researchers or hackers is, their tingly hats are tingling because they're like, this is great because I can do unexpected things. It deviates from the norm. So it's great.
And this is probably further exacerbated by just international mobile providers, right? So it's not just
Yes,
the US companies that are fragmenting or helping to
yes,
fragment. Yeah.
yes,
So then you have like a monster amount of
yes,
divergence, so to speak,
yes.
in the Android ecosystem.
And when you consider that most Android phones are not using the latest Android operating system, most users are using like 2 to 3 versions behind. It leads to even more issues as well. Patching is a very big issue with Android Android phones. So now I'm going to delve into the interactive part, the demo part of the presentation. And first, before we reverse engineer the application, let's actually see the application. Okay.
So you're booting up the COVID-19 app?
Yes, I'm booting up the COVID-19 app. If I might have to come back to
All right.
that. uh, so yeah, we might start our demo and then I'll come back to that.
So wait, I see that you're using this intro to Android security VM. I believe that's something that you made. So can we talk a little bit about that? Plug it. I don't know.
Yes. So yes, the intro to Android security is a virtual machine that I created that has the standard uh, Android hacking tools. It was inspired by Android Tamer, and it was built up on top of Ubuntu 18.04. And so just to sorry, let me so I inside the virtual machine there are additional folders, dynamic analysis where you can look at the application, look at an Android app while it's running, manual analysis while reviewing the app while it's not running, penetration testing, looking at web responses, programming, Python, SQL, like reporting, documentation matters. Got to have good documentation and
Right.
reverse engineering. So uh, this is what is added for the virtual machine. So while waiting for the Android emulator to start, I will talk about the first tool that I use, APK tool. But first, inside the virtual machine, I have insecure apps inside the documents folder. And my documents folder will look a little different than yours because I have other apps that I play with. And so essentially, so all of the insecure apps will be here. So I'm going to use the first tool, the APK tool. And what the APK tool does is it allows us to decompile an Android app similar to its original form. And by doing that, we can look under the hood of an Android app. So let me make this bigger, and I'm going to go to the documents folder and I'm going to type the command and explain. So APK tool, and then I'm going to use the parameter D for compile, and then the name of the app, which is My COVID app. So the COVID app is really not called My COVID, but I changed the name to kind of give a little anonymity.
Yep.
And as you can see, APK tool is decoding the app. And I think we might be in luck with our emulator. Okay. Yeah.
So this sort of dumps out all the jars, right? All the Java components
Yes.
that represent the entire Android app.
Correct.
Okay.
I'm
And,
trying
and the
to.
VM. Oh, go ahead.
No, go ahead. Go ahead.
Oh yeah, no, I was just going to say the VM that you created, you made this because there basically wasn't anything that compiled all the tools that you wanted in one place, right, for what you're doing.
Correct.
This is a nice one-stop shop. I can
Yes,
link in the chat.
correct.
Cool.
There's
And
a question in the chat around
yes,
do you use MobSV, which I believe stands for Mobile Security Framework? I think it's like
yes, it's
another way.
part.
Yeah,
Yes, I have it in the. It's part of the virtual machine,
cool.
and the emulator. I might have to come back to this, everyone, because the
You got to give that thing more resources.
I know.
Give it all the memory.
Yeah, I'm gonna have to come back to this.
For me, it's always
So
forgetting. Oh, go ahead.
yeah, the APK tool, as Nancy said, downloaded the jars the for the Android app. In this case, the My COVID. And with doing this, there are three folders and a file that is created. The folders are res, smalley, metainf, and the file is Android manifest.xml. And I will discuss each of those separately with the next tool that I used, and that is JADX GUI. And you use JetX GUI to reverse engineer an Android application. So you open JetX GUI, and we're going to point it to our Android application, in this case, My COVID, and double click. I always do that. And we are effectively looking at the source code. I can. And we are effectively looking at the source code of the COVID app. And this is written in Java. So going back to the folders that I was describing, the first folder I want to talk about is the res folder. And you could think of the res folder as a catch-all folder, and it handles everything layout wise of an Android app. So layouts, fonts, colors, everything, user interface, the animations that deal with the Android app will be in the res folder. Second folder is the metainf folder. And this folder you can think of as the integrity of the Android application. It handles hashing, so making sure that the Android application has not been tampered with. and making sure what you have downloaded is what you truly wanted. And then the third folder is Smalley, but I will talk about that in relation to the code. So if you look to the right of the screen, you will see Java code. And at the bottom, sorry if it's small, you'll see a tab that says Smalley. And if we click that, so Smalley is pretty much the low level inspection or low level code for an Android app. Most times you will not be dealing on at the Smalley level, but when you decompile an Android app, you will see the Smalley folder. So I wanted to talk about it. And you will, and finally, the last file that I wanted to talk about was the Android manifest. And this is the coup de grace of Android apps. So every Android app has an Android manifest. You could think of this as the skeleton of an Android app because it describes everything that is needed. So, for instance, it describes permissions, and we can see that on from lines 4 through 9, where it has internet, Bluetooth, wake block, foreground services. It describes different components of an Android application. One such component is an activity. You can think of an activity as which represents a screen inside of an Android application. And in an Android app, you'll have multiple activities, but you will have one main activity. And the main activity starts on line 11, and that is represented by the exposure notification activity. And we can tell it's the main activity because we see the main here and launcher. So the exposure notification activity is the main activity. And we have additional activities here on from line 17 through 23, such as how it works activity, exposure about activity, and shared diagnostics. Next, we have a broadcast receiver, and we can think of a broadcast. Um, I'll come back to broadcast receiver. On line 33, we have services, and which is another component. And so there are three services inside of Android. There's a foreground service, and that's a service that a user can interact with. So you can think of this as when you download a file, you can pause the download, you can stop the download, so you can interact with that service. The service being downloading the file. Second type of service is a background service. That's a service the user cannot interact with. So that is an example of that is syncing data in the background. You can't interact with that. And then the third type of service is a bound service, which is represented with requests and responses and is only active while the requests and responses are active. So line 33 shows an example of a service, which is a wake up service. Next, we have line 35 is a provider, which is another component, a content provider. You can think of this as a middleman between the app and a back end. So an app is like, hey, I want to interact with this SQL database. And so the app will talk with the content provider. The content provider will talk with the database, and then the database will respond to the provider, which will then respond to the app. And finally, we have receivers, broadcast receivers. And with receivers, they have intents, events, or messages, excuse me. And these events or messages are registered to the Android operating system. So a sample event is when your battery is low. So for my device, when my battery is 15%, I get a dialogue and my phone beeps and it's like your phone is low. So in the background, what happens is the phone is the operating system says the device says to the operating system, hey, I'm at 15%, kick off the low battery event. And the operating system is like, yep, I see it, I have it, kicking it off, and then the phone registers it and has it. And so that's the receiver. So as I said, the manifest describes everything that happens inside of the Android app. And then one final thing that I want to talk about, which is between lines 1 and 2. So I'll call it lines 1.5. We'll see here this uses SDK. And it says a min SDK version of 23 and a target SDK version of 29. So what does that mean? Well, this tells the app, okay, I can use a minimum version and a target version. And these numbers represent mnemonics of the actual Android system, operating system, such as Marshmallow, Jelly Bean, etc. So it's saying I can this app can work in Marshmallow, but it's better if it works in Oreo and above. So be mindful when using Android apps to look at the min SDK version and the target SDK version. Because while the app might work, it might not be at its best or optimal performance. Now, going back to the code, we see on this line some of the code, we can see, such as set content view or get window. But we also notice like this C3673R, and it's like, what is that? I can't make that out. Well, reverse engineering is a double-edged sword. So for researchers, it's great because it's like, ooh, I have this app, I can reverse engineer, I can, start figuring out the logic, and it's great. But for a company, if I have proprietary information, I don't want you to look at my logic. So what the company will employ is something called obfuscation or security through obscurity. And the reasoning behind that is if I make my code illegible or not intelligible, that will thwart you, or you will become so frustrated that you will not want to look at my code. You will not want to research my app, and you would just move on. But there are commercial products that can be used to de-obfuscate or try to find the logic inside of an app. And while these tools will not get you 100% coverage, they will get you, depending on the app, they could get you a good amount of coverage to get you a good starting place. So I should point out that JetX GUI does try to de-obfuscate as much as it can, because we here, and sorry, it's kind of small, but the de-obfuscate button option is checked. So if I actually uncheck that, we will see how the code looks obfuscated. Excuse me, obfuscated. And this is how it looks. So for instance, AAA, B, D, AAA, and it, again, it will be very hard for someone to actually try to decipher that. So de-obfuscation is good because it can give you hints of okay, I think the logic is this, and then you can start piecing it together.
I have a question.
Yeah.
So there are obviously going to be some challenges that are universal in reverse engineering an application, regardless of what language that it's compiled in. Was there anything specific to you reverse engineering an Android application that you would like to call out?
Sorry, can you repeat the first part of your question? I was clearing my throat. Sorry.
Oh no, it was just like it was lead in. It was like, all right, there are some things that are universal to reverse engineering applications,
Mhm.
right? Like, so you're going to end up seeing obfuscated code, for example,
Yeah.
which you already showed, right? Were there any challenges that were particular to you reverse engineering an Android application? I know that obviously the languages are different. Is there
Yeah.
anything you can call out?
Yeah, I would possibly the first is of course the obfuscation, because especially trying to find the logic, it's very hard, and especially something as big as this application, that was very hard. So I would definitely the obfuscation, definitely that.
Okay, but there's nothing specific to say like since my understanding is that you're looking at code that
Hmm.
isn't decompiled and has like a VM in between already. Like there's nothing different from doing it. It's like say with a C binary. Um, no, pretty much
Nope.
the decompiler does the work and you're good. Okay, cool.
In the Android decompilation process, can you rename some of those obfuscated variables to something a little bit more reverse engineering friendly? So you could say like, okay, I think this is I don't know, a function that does a thing. So, you
Right.
know,
Yes. Yes, I believe so. Yes. And um I've seen videos done on it. I really haven't tried to do it because I'm always afraid I'm going to I'm going to break it.
yeah,
So, yeah, but I have seen it done where people where you start renaming things inside of the code base, and then kind
yeah,
of, yeah, helping to
like
build the picture.
yeah, totally. Like in a lot of reverse engineering, I think you have to do that to keep your head straight around what is
Yes.
going on. Yeah.
Yes.
So at least
Yeah.
for me.
Yes. Yes.
Follow
So,
up. Oh, sorry.
oh, we're
Follow
we're
up
di-
to that. Do you have any other tips while reverse engineering? Because I'm awful at it.
I would say keep an open mind, and I have a real propensity of getting tunnel vision, so I have to like get up and like walk away and exercise and like clear my head, because after a while, and I can only speak for myself, my eyes will start to glaze, and then I'll start missing things. So it's like you have to look at this, especially with like a clear head, and like when you start feeling like you it it's escaping you, or you're really not retaining, it's time to get up, go for a walk, get the blood pumping, and then come back.
Yep. All right, let's keep going
Thank
with
you.
this app.
Yeah. So what did I find? So, well, the first was reverse engineering, but that was kind of like a gimme because you can do that with Android apps. The second potentially was code tampering, and and I say potential. So I renamed the COVID app, and so I use this for it. A shameless plug here. DEF CON Biohacking Village. I actually created the mobile challenges. So while this example is really silly, what I did, I'm going to illustrate this with the even nefarious point. So essentially, what I did was change this line here, this logger, to pretty much say St. Elvis, which was the fictional hospital, will never find this, and then the flag, which pretty much is, every app has a main activity. So I was saying, potential code tampering because what happens if I potentially change the logger instead of this line to dump a patient's profile? Like, I wouldn't do that because of the ethics and the nature of this application, but theoretically, it could be done, right? Inside of the logger, dump the profile and have like information that ties back to a particular user. So that could be done. I say a potential because I'm not going to do it, but it possibly could be done. And then finally, extraneous functionality. And so now I'm going to explain those things and how it relates inside of the mobile top 10. So the first, as I mentioned, code tampering, which is pretty much a catch-all, and that's pretty much a tampered version of a mobile app, and it contains malicious content. You re-sign that app, and then you publish it to a third-party app store. And so that's the example I gave of potentially changing the logging to actually dump a patient's profile. And again, I won't do that. You shouldn't do that. Disclaimer, don't do that. Use that as an example. So some ways to remediate against that is the app must be able to identify any code integrity violation and react suitably to it at runtime. So, meaning when if there is code, dangerous code, essentially the application should not run it. It should just be like, okay, this application code is dangerous or it looks suspect. So we're going to um, contain it and we're not going to run it. Or you can implement anti tampering techniques such as checksums, digital signatures, code hardening, or any other validation method. So if I have an app and the checksum is ABC123, and it says that on the website, but I download the app and my checksum is DEF XYZ. Well, those checksums don't match. So then I know whatever I downloaded is not the correct app because those values don't match. So it's a way to a validation method to make sure that what you're downloading is truly what you're using. And then the second, as I said, reverse engineering, which was pretty much the gimme because you can do that fairly easy, as I shown with Android apps. And you decompile to perform code analysis, and that's to look under the hood to inspect, understand, and modify the code to include harmful functionality or transmit undesired advertisements. And so an example of this is possibly, don't do this, download Instagram from the Google Play Store, which is the official repository for Google, for Android apps is the Google Play Store, and reverse engineer the app and add malicious code to capture login credentials. So a way to remediate against this is not allow the app to deobfuscate the code using tools like IDA Pro, Hopper, or ProGuard. So these IDA Pro, Hopper, or ProGuard are the commercial tools that I was saying earlier when I was talking about JADX GUI that reverse engineers employ to aid them in trying to deobfuscate because I really didn't show, but trying to deobfuscate by hand or manually can take months. And it's just like, that's a long time. So you will want to have these tools to kind of aid you as much as it can. So that's the remediation is not to allow to deobfuscate. And I kind of shook my head with that and scratched my head because depending on the app, it seems like while you might not get 100% coverage, you'll get a good, depending on the app, you could get good coverage of deobfuscation.
I have a question. Okay,
Yes.
so how do you not allow an app to be deobfuscated? Basically, is there an on-off button? Is there a snippet of code that you should include? How does this work?
Yeah, and that's why I was shaking my head because
Like,
that's what it was saying inside of OWASP, but it was like not that I'm aware of that there's a on off switch, so that's why I was kind of like, this is kind of weird. And I'm open, but it's like I haven't seen it, and if there is, please enlighten me. Yeah, I would like to know.
Yeah, I don't think so. I think this
Yeah.
is the
Yeah,
reality we live
because
in.
it's pretty much you can use them. So I was like, that's kind of weird.
I
Hmm.
saw a talk once at DEF CON, I think like 4 years ago, where someone presented how they wrote an app and they were able to compile it so
Hmm.
that when it was decompiled, it was all move instructions, MOV instructions, rather than
Hmm.
like add, compare, any other sort of.
Hmm.
So it was like, it would be like chaos for a human brain to try to figure out like what's going on there. But I'm sure you could probably write a tool. I don't know. I'll
Yeah,
link to that talk because it was really, I was like, my mind was blown. I'm like, oh my God, the whole thing's in move command.
yeah. And then the
Anyway,
and then um and then the final, excuse me, is extraneous functionality. So many moons ago, I was a developer in a former life. And when you're developers, especially when you're in the implementation phase of, building a product, you most times you'll have like additional functionality, debug pages. For instance, like if the app doesn't work, you'll go to the debug page to figure out what part of the functionality doesn't work. And while that's good in the implementation phase, what happens most times is when you ship the product and then the product goes live or goes to production, you don't remove that piece of code. So what happens is the debug pages, the configuration pages lives, and it's like consumers can access that, right? And as the name implies, it's extraneous because depending on what you have in those configuration files or those debug pages, a consumer or a hacker can learn a lot about your application. So ways to remediate is to examine the mobile application's configuration settings to detect any hidden switches, and if they're there, remove them. And if you have debug pages, just remove them, delete them. So it's pretty much before you go to production, do a final code sweep of your code just to make sure that there's no extraneous code. Like everything is accounted for. And now the last part.
before
Yes.
before sorry, there's a question in the chat. Any good repositories for vulnerabilities and how to fix them from the OWASP top 10, which developers can use while addressing security patching? So I guess basically the question is, how do you know you're doing the right thing? Like, what are there any good best practices guides?
For mobile, there's the
Yeah.
OWASP Mobile Security Testing Guide. I think it's version 2 or version 3, I believe. I would definitely check that out. I think it's like 200 pages, but
Ooh.
that is pretty much like the standard for like mobile apps, and it goes through the top 10 and then ways to remediate. So from a mobile standpoint, the mobile MSTG or the mobile security testing guide is what you will be using.
All
Oh,
right, just linked it in the chat. Thank you.
okay. So now continue learning. So as I said earlier, the virtual machine intro to Android security has additional apps. The mobile security testing guide hacking playground. So there's a hacking playground that has that are vulnerable apps to kind of get you up to speed on mobile security. Another app, Diva, which again is insecure, IG Learner, and the Uncrackable series. So to actually, what you will want to do is push these apps to an emulator, which I tried to show, and the demo gods were not with me today, or an actual physical device using Android Debug Bridge. So I actually have a YouTube channel, and I have a video explaining this, and because that's outside the scope of this presentation. But if you want to know more, just go there. And then finally, additional learning. HackerOne has a mobile security playlist, which is free. That's what the F stands for. And then additional challenges. There's the MobiSec challenges, which are free. And then Pentester Lab, Android challenges, which are paid. And I think you can do subscription base where you pay every per month, or you can do per year. And there's student options, and I think also with your job and things of that nature. I've used Pentester Lab. I really like them a lot. So I have good things to say about them. And that is it. So are there any additional questions?
So, a question around just the Android ecosystem, right? There's new versions of Android every year, just like iOS changes. How do you stay up to date on, the new up and coming Android security features, application development features, as things change? What is your process for staying on top of that?
Yeah, so Google, because Android is handled by Google, so Google actually does a really good job of having like Android bulletins or Google bulletins in relation to Android. So I actually try to read those, and if they don't do them monthly, it's at least quarterly, and I try to read those. Also, I'm really Twitter is like my vice. So it's like I'm always on Twitter looking at articles and things of that nature, and all of the latest vulnerabilities, and really engage seeing what others in the community, the infosec community, are doing. And that's pretty much how I stay up to date.
And for those that are just kind of new to this, I'm assuming you don't have like 400 old Android phones sitting on your desk right now.
No, so
How do
that's
you
what I
test
was trying to
Android?
show. Yeah, that's why I really wanted to show the emulator, because most people will tell you that um, best practice is to actually have a rooted device, because again, with the rooted device, that means you have all functionality of the phone, including the system. So that's, if that's ideal, if you can do that. But if you can't do that, you can use an emulator. And so that's essentially what I used in the beginning, was an emulator, an
And you
Android
could and
Android.
you could emulate any version of Android, right? Like you could pick, you know, yeah.
Hold up. You said you used to use it in the beginning. What are you using now?
I actually have a few well, I converted my old phone into a test phone. So
Okay.
that's what I've done. So I've converted one of my Sam, like a S6, a Galaxy 6, into like a test phone. Like I deleted everything and I changed it to a test phone. But again, emulators are good, because it was in the beginning I wanted to start, but it was like I was apprehensive, because I was like, I have an Android, but I really don't know how to start. And then it was just like I downloaded the emulator that one day, and I was like, well, let's just go. So yeah, I would just say, if you're interested in this field, just start. That the hard part is starting. Trust
And the VM that you made, the emulators were all
me.
on that VM, so someone could download that
Yeah.
VM or the VM and get started today.
Yeah, and I try to, and also I'm welcome to feedback. So it's like, if you're using the VM and you're like, hey, there's this tool that I see and it's not on the VM, I would try to add it. Or if there's just feedback, I'm definitely open to it because I want it to be used by the community.
I have one more question.
Yes.
Do you know why Google stopped naming Android versions after desserts?
I don't, but I'm kind of upset because I liked it.
Yeah, me
Yeah,
too.
I really liked it because it was like, ooh, yeah, it was really good.
Oreo. But I think they stopped a couple of years ago. I haven't heard of a new dessert lately. So,
Yeah, it's like, yeah, and I was like, yeah, I
I mean,
didn't.
it's not like there's a shortage of desserts out there, you know? It's a
Yeah, but
pretty
you can always
rich
make
naming
new ones.
ecosystem. Yeah, exactly.
Yeah, you can always make new ones. So, yeah, it's again with an Android, it's more, the barrier to entry is lower because again with actually reverse engineering, you can just with JADX GUI or any other the APK tool, you can just decompile pretty easily. So it's like, if like I said, if you want to, if you are like, hey, I think I want to try it, just give it a go. And it's like, because we need your brain and it's like we need your perspective.
Thanks.
Cool.
Okay. One question. You said that you made your phone into a test phone. Is there anything other than deleting the well, sorry, deleting the I guess the personal information off of it, that you would do to prepare a phone to become a test phone?
So as I said earlier, if you jailbreak or root a phone, if
Right.
it's under warranty, you that pretty much voids your warranty. So that phone was out of warranty. So don't do it to your current device, right? Because it's like, if you and then you take it, they'll know, and that pretty much voids your warranty. So definitely use an old phone or go to eBay. A lot of times, what people will do, and I've done this as well, is go to eBay and just get old phones from there and use that as testing devices. But do not use like your current phone
Yeah,
for
obviously.
testing.
Don't break it, right. Okay, cool.
No,
Or
no,
possibly
no.
break it because there is
Yeah,
that
uh-uh.
small chance. Okay. And then I guess if you want, let's talk a little bit about what's next for you. I know I've been looking at your blog. It's a fun read. If anybody hasn't seen it,
Yeah,
definitely do. And you
Yeah.
are very much inviting people to collaborate with you on it.
yeah. So so I'm at Adjunct, so that keeps me pretty busy. The CTF coach for the US cyber games, so that keeps busy. And besides that, I don't have too much really going on. That is enough, and that pretty much keeps me busy. But will, YouTube, that is on my bucket list to kind of produce more videos and more content. So yeah, that's on my bucket list to like get that up and running again. So but it's a lot harder. It looks so easy, but it's so hard.
Yes, there's so much prep even in this show.
Yeah, it is. But
Yeah.
yeah, I love sharing knowledge with the community. So
No, you're
that's
great at it.
definitely
Yeah.
on my bucket list.
Yes, we love to see it. Thank you. Well,
Cool. I think we are, yeah, I think we're wrapping it up here, guys. Any final thoughts here, Jasmine, for our audience, new to Android, new to reverse engineering mobile apps? Any special hot tips that got you moving on?
No, I would just the Source Forge, I can provide that link. If you are interested in learning about
we
the
already
intro to Android security.
we posted it. Don't
Yep,
worry.
Okay,
we got
good.
that
We
one in.
Yeah,
we were like
so just
stalking you
yeah,
on while the show was
click
going on.
when you go, because people are like, where is it? So when you go to SourceForge, click on external link, and then the emulator, the Android x86 emulator is the first, and then the latest three versions of the intro to Android security virtual machine is there, and the latest version is 2.2.0. So, and again, the username and password is the same for all versions. Android username and password security. I try to make it easier for people to really not be like, what's the password for this? So
Oh.
yeah, and it's just get started because paralysis, starting paralysis, I suffer from it where you overthink. If you have an inclination, you like, hey, this looks fun. I think I can do it. Just start. That's my words of wisdom.
Yeah, I love it. Just dig in.
Yeah. And
Cool.
wanted to say that in the chat, we have a really loved your session. Thank you. I also feel the
Thank
same.
you. I'm so
Yeah,
sorry
Yeah.
the demo gods were not with me with the
totally.
demo, but what I'll do is I'll send screenshots possibly to show how the app looks because yeah, it's the demo are fighting me today. I guess I didn't make my offering in time. So
Or yeah. Cool. All right. So thank you everyone for joining us. We are back here next week with Kinnard McQuaid. We're going to be talking about cloud security tooling for the sole practitioner. So please join us next Sunday, 10 a.m. Eastern, 2 p.m. UTC. And with that, thank you, Jasmine. We really
thank
all learned a
you.
lot. Thanks for all the work you've put in here to show us Android security. Thank you to my co-host, Amy. And thank you to our audience for joining us again. See you all next week.